Good day to all students. Today I will be discussing about regioselective, regiospecific as well as chemoselective reactions. Let us understand these forms of selectivity because these are very much important for you to study different kinds of organic, inorganic reactions. In this slide, as you can see, I have given the title Regioselective, Regio-specific and Chemoselective reactions. Let us understand these. Here you can see these are the regioselective and regiospecific reactions. I have taken a very simple example where there is removal of hydrogen as well as OH, that is proton and OH, HOH, and this is giving rise to two types of alkenes, A as well as B. Suppose you are going into a particular pathway and then you find two routes for the same. One route will give you the pathway A, which is the house of your friend, and the route B will give you another house of another friend. In this case also, when you are heating it with H2SO4, you are following two pathways. Either the H is removed from the more substituted carbon or from the less substituted carbon. In any case, as you can find here, there are two products, and as you all know that A will be the major product of the reaction. Regioselectivity deals with those reactions where there is a functional group and there is preference of selectivity among the different sites of that functional group. Mind that there will be only one functional group involved and not more. Okay. Now, this is a regioselective reactions because there are two options and then you are actually getting A, which is one of the options in the more amount compared to that of the B. Now let us moving into the next slide. As you can see that all regiochemical reactions are not regioselective in nature. As we have discussed in the previous slide that regiochemical reactions involve the reactants giving rise to two regioisomers. Regioisomers are what? Where there is a one functional group and there is a selectivity among the different sites of that functional group. And one product has to be more compared to the other product. If you find out a particular reactions which is giving rise to only say 50%. For example, as you can see here, this is 50%, 50%. So this reaction will not be regioselective and it will be told that this reaction doesn't involve any regiochemical control over the process. Hopefully this is clear. Now let us discuss some other aspects of regioisomers. When you were studying stereochemistry, hopefully you have got through what is referred to as constitutional isomers as well as the conformational isomers. In this case, constitutional isomers are formed when they are actually not converted to interconverted to each other at the room temperature and they have different bond connectivity. Here you can see this has the same molecular formula. This will also have the same molecular formula. A and B are referred to as the constitutional isomers. Here A dash and B dash are also the constitutional isomers. They have different bond connectivity but they have the same molecular formula. In the previous example also we observed the regioisomers which were the constitutional isomers to each other. Okay. Now let us take a particular example. This is the addition of bromine to your alkene. As you can see here, actually HBr is getting added and the bromine is actually getting added to this carbon. Now there are two options. One is a major one. I think I have done a mistake here. Actually this will be the, no, there is no mistake. From the one, if I add the HBr, there will be the anti-Markov-Nikov rule in case of peroxide, and in case of Markov-Nikov rule, it will be the from the more substituted carbon. Bromine will be attached to that. Now these two reactions involve the one as a major product, and it is obtained with 100% yield and so it is referred to as a regio-specific reaction. In the next slide, as you can see, this is the example of hydration of alkenes. Here, suppose this is the olefin. Now there are two options. One is OH being added to this carbon. Another is OH being added to this carbon. In this case of the BH3THA, OH is getting converted to this carbon, which is not having the phenyl group, and in case of HJOSC2 and NaBH4, this OH is getting attached to that carbon which contains the phenyl. So these two isomers are obtained with the 100% yield, and these all reactions are regioselective in nature. Since there is a one functional group and there is site selectivity among the same functional group. In the next case, that is after the hydration of alkene, this is the hydration of alkynes in the nature. Now in case of alkyne also, there is a triple bond, and we are adding the two reagents, and among these two reagents there is the CHO and this is a C double bond O. Now this is a major and this is the major product. So these two are regioisomers are getting generated, and the reaction is actually having under regio control. Now if you carry out a particular aromatic substitution, say in this case the aromatic electrophilic substitution. In this case, if you carry out a particular electrophilic substitution, say you are having different options, ortho, meta and para. As you can see here, I have shown in this thing that there is a nitration, the ortho, para and meta isomer 58.4, 37.2 or 4.4%. In this case, this is the aromatic electrophilic substitution, and this is also an example of regiochemical control, because there is a selectivity of the NO2 to get attached to which site of that benzene. So aromatic electrophilic substitution are also represent examples of what is referred to as the regioselectivity. Now we have some important components of two reactions. This is the Diels-Alder reaction. So far we have discussed what is the regioisomers, the constitutional isomers, they are, and the different site selectivity over one functional group. In the second case, as this is the regioselectivity, now as you can see, this is an important type of reaction which is a Diels-Alder reaction. In the Diels-Alder reaction, actually you can see here, this is the one substituted diene getting actually attached to the dienophile and giving rise to 1,2 product ortho major and 1,3 product meta minor. Now here, as you can see, these are the stereogenic or chiral centers present here, but the attack may occur in this case or in this case. So it depends on the reaction condition. Actually, it is explained by FMO and many other concepts that which addition will be taking place. Our concern is that to show the regioselectivity which is present in case of the Diels-Alder reaction. As in case of this is 2 substituted diene, this is adding to the dienophile, and this is 1,4 product is obtained as a major product, and here 1,3 product is obtained as the minor product. So in this case, the regioselectivity in Diels-Alder reaction is being observed. Now, so far we have discussed that what are the regioselective reaction. In our concept, there were the 3 things. One was what is the regioselective reaction, what are regiospecific reactions, and what is the chemoselective reaction. Let us just recapitulate this one. The first one is that the regioselective reactions will involve a particular reaction in which there is site selectivity of one functional group. Along the one functional group, there will be additions of the reagent to different sites based on the conditions of the reactions. Now in this case, as you can see, regiospecific, the reaction we will be calling when there will be 100% generation of the product, and in case of 80-20 or 60-40 or 70-30%, or there may be 3 products, regioisomers, then it is referred to as what is referred to as a regiospecific when it is 100%, and other than that it is known as a regioselective reaction. Regioselective reactions involve the constitutional isomers in this case, because they are all constitutional in nature. and they are not conformations. They have the different bond connectivities, and we observed different kinds of regioselectivities which is observed in case of addition of HBr, addition involving the double bond addition according to Markov-Nikov or according to the Markov-Nikov anti-Markov-Nikov's rules by the help of peroxide. We also observe the regioselectivity which is actually present in case of the Diels-Alder reaction. After discussing regioselective reactions, now we will be discussing about what is referred to as chemoselective reaction. In case of chemoselective reactions, you will be having two functional groups. Out of this, only one functional group will be attacked by the reagent and the other functional group will remain intact as it was. As you can see here, this is a double bond, and here this is the olefinic double bond, and this is a carbonyl double bond. Now the carbonyl group remains intact, but here double bond is actually getting reduced. So this is a good example of what is referred to as chemoselective reduction. In this case, in case of chemoselective reduction of C double bond O over C double bond C, as you can see, the carbonyl group is getting reduced and it is giving rise to the OH, and here the double bond remains intact in this case. So this is another example of what is referred to as a chemoselective reduction of C double bond O over C double bond C. Now let us go through some another examples of what is referred to as your chemoselective as well as the reduction. Also we will be discussing about what is referred to as the oxidation reaction. Now so far from the chemoselective reactions, we have understood that there will be two functional groups, and out of these two functional groups, one will be attacked by the reagent. And in case of regioselective reaction, there will be one functional group and there will be two options for the reactant to actually attack, and the one site will be attacked in predominance or preferred over the other site. Now, after discussing this, let us come into the another chemoselective reduction process of alkenes over alkenones. Here you can see this is the alkenone and this is the alkene. The alkenone is getting actually intact, remaining intact by the help of triphosphine rhodium chloride, and in case of this double bond is actually getting reduced in presence of this reagent. So this is an example of what is referred to as chemoselective reduction of alkenes over alkenones. In the next example, actually we will be discussing about what is the chemoselective reduction of alkynes over alkenes. In this case, as you can see, this is the hydrogen palladium CaCO3 reaction being taking place in presence of quinoline. Now there is a triple bond, this is a double bond, and then the double bond remains intact and the triple bond is actually getting reduced, giving rise to the double bond. So this is an example of what is referred to as the chemoselective reduction of alkynes over alkenes. Now likewise, we also have the chemoselective reduction of COR over CN. In this case, that is a chemoselective reduction of COR over CN. We have CaBH4(2), and this is reacting with the MEOH in case of COR as well as CN. Now COR is getting reduced, but CN is actually remaining intact in this case. So this is referred to as the chemoselective reduction of COOR over CN, as you can see. Now there are many examples of what is referred to as the chemoselective reduction of carboxylic acids in presence of esters, nitro and cyano groups. Here we have COH and C double bond O. There is a BH3, SME2 and tetrahydrofuran giving rise to the reaction. As you can see here, the COH group is getting reduced, but C double bond O group, that is the ester group, is actually remaining intact. So this is another example of what is referred to as chemoselective reduction of carboxylic acids in presence of esters, nitro and cyano groups. Now let us come to the another slide. Here there is a chemoselective reduction of epoxidation of alpha-beta unsaturated ketones over alkenes. Now look at this reaction. This is an alpha-beta unsaturated ketone and this is the chemoselective reduction of epoxidation of alpha-beta unsaturated ketone over alkene. Here the alpha-beta unsaturated ketone is getting epoxidated, that is the epoxidation is taking place, but here the double bond is remaining intact. So this is the two functional groups. The reagent chooses the double bond of the alpha-beta unsaturated ketone for epoxidation. In the next example, as you can see, this is a chemoselective reduction of epoxidation of alpha-beta unsaturated ketones over alkenes. Here, the alpha-beta unsaturated ketone is remaining intact as it is, but here, due to this double bond, is getting epoxidated by the reagent. So, this is the chemoselective reduction of epoxidation of alpha-beta unsaturated ketone over the alkene. Now, when we discussed about the chemoselectivity, we discussed that there will be two functional groups and out of this, one functional group will be chosen by the reagent. But this is not the case always. As you can see in this example, the chemoselectivity of the reagent for same functional group is actually being observed over here. In presence of NaSH-MeOH, there are two nitro groups and out of these two nitro groups, one is being reduced but the other remains intact. So chemoselectivity can also be observed in presence of the same functional group as it can be. Now, let us conclude the total discussion on regioselectivity, regiospecific reactions as well as chemoselective reactions. In case of regioselective reactions, as you can see, the reaction involves one functional group and out of this one functional group, it is actually getting attacked on the different sites with the preference by the reagent. In case of regiospecific reaction, the idea is the same, but one of the product, although there are options, is formed with 100% selectivity. In the third case, that is in case of the chemoselective reactions, in case of chemoselectivity, there will be two functional groups, not necessarily as we saw in the last example, but generally there will be two functional groups and out of these two functional groups, one will be chosen by the reagent for attack and the other remains intact. So, there is chemical selectivity of the reagent over one functional group compared to the other. So, in case of the chemoselective, these are the processes. Now, chemoselective reactions can also occur in case of the different kinds of, you can say the different kinds of the same functional groups or different functional groups, but regioselectivity occurs in case of the same functional group always. So, with this, I would like to conclude my discussion. My next topic will be on stereoselectivity, stereospecificity, as well as on the basis of the different applications of the stereoselective reactions.